How to perform residential electrical inspection course. I am a certified electrician. I have a 2-year degree in this, and I love what I do. I love being a home inspector, and hopefully all y'all do too. Um, so this is not a code course. This is an inspection course, and the course is formal representation of everything that we do. The course may be checked for updates from time to time. You want to make sure that you're continuing understanding that things change in the electrical world all the time. And this code, or sorry, this is all brought on by the 2021 International Residential Code series. So I'm going to kind of go with that. So number one thing is electricity kills. The inspector's safety is always top priority. Whenever you're doing a house, make sure that you're staying safe. Safety for your clients, safety for your occupants. A lot of times, like when I'm taking off that electrical panel, I make sure that if I have somebody behind me, I say, hey, just stand over there just in case. We want to make sure that we stay safe. If any electrical conditions appear unsafe, stop what you're doing and recommend further evaluation from a qualified licensed electrician. And build to code. This is always one of those few areas, it's very gray, that most inspectors would report as in need of correction, system or components or whatever it is. But built to code, when the home was built, but it might have been to code. And today, standard says that it's unsafe. So you have to kind of understand where things are, like in absence of a GFCI protection in the kitchen, for example, would fall into that category. Many home inspectors might put that in as in need of correction, but the house was built in 1940. So you're not going to see that. So many home inspectors inspect the home or building without regard of when it was built. And you want to make sure that you're doing that on a regular basis. Um, Whenever you have the chance, explain to the customer, hey, this was built back then. That was great. Today, we'd like to update the standard to this because it's more safe for you. So the primary reason is safety. And the home inspector should be especially cautious when evaluating the panel boards and electrical system and distribution panels because it can kill people. According to the InterNACHI home inspection standards of practice, a home inspector is not required to do anything that the home inspector feels is unsafe, including removing dead front electrical cabinets or panel boards or exposing electrified or live components, electrical components within whatever it is. So safety is number one. And a lot of you, especially like for you that are in Florida, we have the 4 point where you're supposed to take off the panel board. If you feel unsafe, don't do it. Just say, this feels unsafe. Recommend a further evaluation from a licensed electrician. Now, the standard of practice, be sure to refer to the standards of practice and read the requirements and the exclusions for conducting the electrical inspection of the home or the building that you're doing. The home inspection standards of practice is found right in InterNACHI. You can read it, get to know it, make sure that you are familiar with it and understand what you're allowed to do and what you're not allowed to. The inspector is not required to inspect the service entry, or sorry, the inspector is required to inspect the service entrance conductors, the main service disconnect, the panel board, the overcurrent protective devices such as circuit breakers or fuses, and service grounding and bonding. The home inspector is not required to remove the panel board, the the cabinet cover, or dead front. So you can read this short article about the standards of practice at www.nachi.org/exceed dash or dash not dash exceed. Sorry, that was a lot, but that's what we do. A home inspector is not required to remove the dead front cover. And you hear me say this over and over again because it is so important that this is engaged in your head. One time I went to a inspection and I felt it was unsafe because when I put my hand on the back of the panel, it actually had a little bit of current running through it. I don't want anybody to not go home safe. We need to go home safe. We need to make money for our families and ourselves and stay safe. If any doubt whatsoever of your safety, anyone's safety, refer to an electrician, contractor, especially. Inspectors should follow these basic safety rules when inspecting live electrical components. And if you want, you can screenshot this right here. It will, and read it, get to know it, make sure that you keep it in your heart. So I'll give you a few seconds. So if you want to take a screenshot of that. So you want to definitely wear protective gear, remove your wristbands. And matter of fact, jewelry too. The big thing is like little rings. We're not supposed to wear like nylon or polyester. Matter of fact, you probably don't know this, but your clothes actually have calorie counts, and that's how fast it burns. And so just make sure that you're staying safe. Visualize, inspect what you can inspect. Okay. Okay. Now, one challenge home inspectors face during electrical inspection is using the current terminology. Incorrect terminology can make an inspector appear inexperienced or unprofessional. For example, a wire is more properly called as a conductor. Understanding proper electrical terms help inspectors communicate clearly, identify defects accurately, and recognize improper and proper conditions. So you want to make sure that we're continually doing that. Common inspector term, electrical terms are implicity, which is the maximum current and conductor that can safely carry through any type of conductor wire or through that circuit breaker. Appliance. Now that's an equipment. Of course, you all know what appliances are. If you don't, like a refrigerator, air conditioner, clothes washer, dryer, things like that. An AFCI, which is an arc fault circuit interrupter. You got AWG, which is the sorry, the you got the AWG, which is the American gauge or wire gauge, and that's the standard sizing system for conductors. The large number indicates smaller conductors. So that's kind of how that works. Bonded means connection to provide electrical continuity. Continuity. Can't speak today. Branch circuit, conductors between the final overcurrent device and the outlet or fixtures, whatever that is. A cabinet, an enclosure with a door, such as an electrical panel cabinet. So circuit breakers, everybody should know what a circuit breaker is. If you haven't, um, I'm really glad you're taking this course then. But it's an overcurrent safety device and open open up the circuit if something trips or something overloads it. So it's to prevent short circuits, uh, and it works very, very well. Dead front. Now that is the cover protecting the occupants from energized parts inside the panel. Current, now that is the flow of electricity that is measured in amps. And we'll get into that a little bit more as we do this webinar. The feeder, now those are conductors between service equipment and downstream overcurrent devices or subpanels. And now a device, now of course that's an equipment that controls electricity but doesn't not use it, such as like switches or thermostats or disconnection means. So a device used to disconnect conductors from their power source. You'll see that like on air conditioners, you'll see that device that you can pull out that the switch or I forgot what it's called. But anyways, it's a disconnection device and it should be within reach of where you can work on it and actually see it. So um, you got KC mill, which is conductor size designated use for conductors larger than 4 gauge wire. You got the hot conductor, which is the ungrounded current carrying conductor, typically black or red. You got the GFCI, which is the ground fault circuit interrupter. You have the line, that is the incoming side of the electrical equipment. So if you're looking at like a GFCI, a lot of them will have line in, that's what it's talking about, and then it'll have load on the other side. And the load is the over or the outgoing source. So that way you can daisy chain later on, and we'll get into that a little bit later on this course too. The main breaker, of course, is the main disconnect. If you have to shut off all the circuits at once, that main disconnect. Everybody should know what that is. A meter, that's where you're going to get charged for electricity. It's the device that measures the electricity usage, and that's what charges you for what you're using. A neutral conductor, the grounded current carrying conductor. Typically, it's white or it's gray. So there you have terminology. An outlet is a point in which electrical wiring systems where current is taken to supply equipment or devices. Examples include like your receptacles, your light fixtures, your smoke alarms, and appliances. Some are hardwired in, some like your dishwashers, things like that. And hardwired means that it is connected directly to it. It doesn't have a plug-in. So a switch is not an outlet because no current is taken or utilized at the switch. Current simply passes through it. So as soon as you turn that switch on, current goes in, turns off. Same thing with like a flashlight with the button. Overcurrent protection devices. The device designed to open a circuit when current exceeds a safe level. Common examples include like your circuit breakers and your fuses. So you can get that. Now, the panel board contains bus bars. It contains terminals and overcurrent protection devices, and it's typically referred to as a home electrical panel. A receptacle, a device installed at the outlet that accepts an attachment plug. And I think you all know what this is. If you don't, put it in the chat. A receptacle outlet, an outlet where one or more receptacles are installed. Romex. Now, a lot of people get this kind of confused. They call every wire Romex. Well, Romex is actually a trademark. It's kind of like tissue paper. When you say you're going to go get a tissue is a brand name, or Kleenex is a brand name. A tissue would be a tissue. So the most common wiring method in residential construction is Romex. Typically 14-2 with a ground wire, a hot conductor, and a neutral conductor. So there you go. Service, the conductors and equipment that they either go underneath the ground or they go over the top. That is your service. So SE and SEU wires, which is SE is your service entrance, and your SEU is typically oval shaped with two grounding conductors and a neutral conductor, only used only to the main service disconnect because it does not contain a separate ground conductor. SCR cable, typically round, contains a hot, a neutral, and grounding conductors, making it suitable for feeders and subpanels after the main disconnect.
Hey,
So
Dirk.
wire,
Hey, Dirk.
what was
Real
that?
quick, can you
Yes,
confirm what slide you're on?
number 7.
Basic terms? Is that
Basic
what you?
terms, yes. Yes.
Okay, thank you.
Am I going too far?
No, no,
Uh,
no. We just had a question in the Q&A, so I just wanted to make sure that everything was good.
okay, yeah, if yeah, we got a lot to cover here, so I don't know if I can keep up with questions and on those slides.
No, it's fine. I just wanted to make sure that your screen was keeping up. So
Okay.
stay golden. Stay
All
golden,
right.
pony boy.
Hey, thanks. I appreciate that. Hey, a little interruption. This is a good time to make sure you thank your sponsor, InterNACHI. So, uh, okay, so where was I? Wire uh, wire abbreviations. Electrical conductor size are commonly identified using several interchangeable name methods. The 4AWG may also be written as number 4 wire for AWG or 4 gauge, which is GA. Larger conductors such as like the 000, also known as 3 gauge wire, a number 3 wire, or simply 3 or 3/0, I believe is how you say it. Understanding these abbreviations help inspectors accurately identify conductors and communicates professionally with the electricians and contract evaluation from an electrician. And a lot of times when I get the callbacks, that's when we actually start talking a little bit more in depth. But for the most part, it's really awesome to know a little bit so that you can get to know uh, how electricians talk to each other. So if that makes sense. So common residential cable types. Residential wiring is typically identified by the conductor sides following with the number of insulated conductors in the cable. You got the 14-2 with the ground, which contains the black hot, and the one neutral, which is white, and then the bearer is the ground. You got a 12-2 with ground, which contains a black hot, one white neutral, and one bearer grounding. Then you got the 10-3, which contains a black and a red wire, and a white wire for the neutral, and one bare ground. Commonly used for the 220 volt appliances, such as like your dryers and your ranges and things like that. As a general rule, the larger the wire number, the smaller the conductor. So kind of think of it like going up. If you look up, it gets thinner. So that's kind of how I kind of visualize in my head. When I'm looking at wire sizes, a lot of times I'll start with the smallest one, which is the 14 gauge, and then I can kind of visualize the size from there when I'm doing inspections. So in the electrical industries, AWG is the most commonly referred to as gauge wire, while larger conductor sizes use the terms OT. And so like one AWG is 1 gauge and or 1/0. So or you got the 2/0 or whatever it is. Using the correct terminology helps you communicate a little bit more with the electrician if or when you ever talk to them. And but a lot of times I'll do like the re-inspects and stuff and talk to the electrician right there, and it's kind of fun. Understanding how electricity works. Now, if you're not familiar on this, we did a class on Electricity 101, and we also did part two of that, which was Electricity 101 part two, which is bonding and grounding. You can learn a lot on those two webinars, and I believe we've had quite a bit of success with those ones, and hopefully it unwraps a lot of the questions that people have with electricity. Electricity can be compared to water, and it kind of uses this as a visual, but remember that water will find the easiest path where electricity goes to all paths. And so, but as a visual, let's just kind of fixate on the water. Water is moving through a pipe. The pipe would be the conductor or the means of transportation for those electrons. So the it's normally called EIR, which is voltage, which is the E, and it's a electromotive force, I believe is what that is. It's the pressure pushing the electricity, similar to water pushing through that pipe. So current is the I, that's the intensity, and that is known as the amps. So current is amps, and that's the I in there, which is the intensity. It's the flow of electricity similar to the amount of water flowing through the pipe. Then you got the resistance, which is the ohms. The ohms is the resistance, and it's restricted flow. It's how much electrons you're actually kind of losing in effect, and that's what electronic devices and stuff do is they actually use resistance to help move the electrons in a certain pattern in a like a electrical board or something to that manner. And that's why they use different types of metals and things like that inside electrical panels. That's how your phone is working. It's just the flow of electricity. And it's similar to the size of the pipe or the kink in, like if you kinked a hose. So we want to slow that down, or you don't want it to slow down. Increasing the voltage increases the current flow, which increases resistance, decreasing the current flow. I hope everybody's kind of keeping up on that. The Ohm's law is I equals E divided by R. So current equals voltage divided by resistance. And electricity, there is also power, which we actually discuss in watts. It's named after James Watt, who invented the steam engine. So he actually gets some credit here. And this is represents the amount of work or electricity that can perform. So W equals volts times, or V times I is basically what it is. So yeah, volts turned times current. Using the water analogy, more pressure, more flow produces more power, just as high voltage or higher current produces more electrical power. I always think of that light bulb. The higher wattage bulb is going to get you better light. So the the four electrical forces: voltage equals is pressure, current equals the flow, resistance is reduction, and power equals that work that you're going to put in there. So that's why understanding just these four basic terms gives you kind of the fundamentals of electrical knowledge. So Ohm's law, George Simon Ohm was a German physicist born in 1787 who helped understand how electricity really worked. Using some of the first electrical batteries ever invented, he discovered the relationship between voltage, current, and resistance, what we know today as Ohm's law. So Ohm came up with this. At this time, his ideas were rejected by his peers, and by his work was largely ignored. He eventually lost his teaching position. He struggled financially for many years, but as time passed, engineers and scientists realized how important his discoveries actually were. Today's Ohm's law was one of the fundamental building blocks of electricity. We are building on the work that's got to give him a little bit of credit. Um, so how does Ohm's law really help us? So Ohm's laws helps us understand how electricity works, how it relates to um, elect to the electrical system, and how it we design this so many different ways. So it tells us how volts, how the pressure works, how the amp flow, how the resistance um, it restricts that work. And together it keeps electrical systems operating safely. So, for example, you wouldn't want to put a 30 amp breaker on a 14 gauge wire because you know that that 14 gauge wire cannot handle such or that amount of pressure. It's going to pop, just like putting so much pressure into a garden hose. If you put too much pressure on it, that hose is going to blow open. So let's just keep it simple. Volts equals pressure. Amps equals flow. Ohms equals resistance. Watts is the power of work that goes out. Two formulas every inspector should actually know. Watts equals volts times amps. Amps equal watts divided by volts. Understanding these basic things can help inspector understand electrical systems and recognize potential hazards. Now, as home inspectors, you might not get all this, and that's okay. What you should get is if you see a 14 gauge wire on a 20 amp circuit, you should be calling that out. Okay. If you see it on a 30 amp circuit, you should be calling that out. Try to understand what relates to what amps. Those are a big thing to look at. The only exception, I believe, is air conditioners, and check the jurisdictions when you do those type of home inspections. So as we saw in with the Ohm's law, resistance is key to the conductor's ability to safely deliver the amount of power that a circuit needs. Okay, so think back to that pipe. The bigger the pipe, the lower the resistance. It's like sliding down a slide, right? If you're a bigger person, you're gonna have a lot of friction there. You're gonna have a lot more resistance. So that's resistance. The conductor material. When evaluating electrical systems, we need to recognize that copper and aluminum conductors are not the same. Although they are both commonly used in residential supply, copper inherently has less resistance to the flow of electrons than aluminum does. For this reason, aluminum conductors are always 1 to 2 size larger than the equivalent of copper. One of the one for every given amperage. So, and as we speak of aluminum, there's single strand, there's solid, and those were typically used in the 1970s. Multi-strand aluminum wires are seen on service entries. A lot of times you're going to see those um, in conjunction with other like uh, higher amperage circuits. So like when you might go into a garage or something and they might have an arc welder or something, and that might be aluminum wiring. It's multi-strand, or it might be copper clod too. So you never know. Um, Larger conductor size. As we have seen, for larger amperage, we need for larger conductors. The following table is a general guide to sizing conductors for feeders and service in single family and dwelling units for the 2-story and multifamily dwellings. It cannot be used for other services or feeders for other applications. For a commonly installed 200 amp service, the service entry cable, the SEU, between the meter and the base and the main electrical service panel. With the with that, you have to have like 4 common um, aluminum conductors for the hots, and the bare has to be a 2 aluminum ground or neutral conductor, and so on and so forth. The idea here is so that you understand that there's a difference between aluminum and copper. So the feeder that you see here at 100 amps would need a number 2 for aluminum, but it needs a number 4. So 4 is actually a smaller size wire, but it's for copper instead of aluminum. So that's basically what this whole slide is talking about. So when you're looking at the overcurrent protection here that's required, all grounded conductors must be protected by an overcurrent device, such as a circuit breaker or a fuse. Their job is to prevent conductors from carrying more current than they were designed to happen. I had an inspection once at a house, and they said that their fuse was actually blowing out all the time. And it's like, well, what do you have running on there? Well, he goes, I got my microwave on there, and every time when I plug in the toaster, it pops. Well, it's on the same circuit. It's going to pop. That's just too much for um, that wire, and it's too much for the 15 amps that it's drawing. So the key point, the breaker size should never exceed the implicity of the conductor it protects. So like the 14 gauge, 15 amps, 12 gauge, you got the 20 amp, 10 gauge, 30 amps, and so on and so forth. The American wire gauge, the standard sizing system for electrical components, is always going to be in your brain when you're taking off that electrical panel. Make sure that, and like I said, I start with the smallest and work my way up from there. I look at the 15 amp, size that wire in my head, and then I can go, oh, that's a 12, that's a 10, and so on and so forth. That's kind of how I do it. As a home inspector, should really look for those solid strand aluminum wiring, because if those houses were built in the 1960s and 70s, the presence of aluminum branch circuit and wiring in a home, it might actually uh, halt some insurance from happening on that house. So it's good to actually call that stuff out. So most Oh, sorry, I skipped a slide here. So this slide here, if you have a chance, actually check this out at a later date. You can actually screenshot this if you wish, and say and watch this video because it is very interesting how Ray actually explains how to take off the electrical cover and so on and so forth. We're not going to watch the video today because it will add a little bit too much time, but check out that video when you get a chance. Um, Most important concept in this entire course is safety. And you're going to hear me say this over and over again. Safety is key. I want everybody who takes this course, anybody who even touches electrical, make sure that you are safe. I want you to go home every night safe, okay? Compared to inspecting a roof or from a ground or whatever, the scariest part of our job is actually the electrical. It's the argument, it is the most dangerous part of our job. And many things can go wrong in an instant. And some mistakes can be fatal. This is why inspectors should understand safety procedures, including what causes electrical shocks, what causes the arc flashes. And if you haven't seen a video on arc flashes, I suggest you look it up on YouTube and see how dangerous they really are. I had a inspector out of Texas, and I don't know if he's here or not, but he was telling me that he took off a dead front cover of a Federal Pacific panel and it exploded right in his face. This is serious. He had skin grafts done. He's a home inspector, and from then on, he never opened up a Federal Pacific panel. And we're going to talk about that a little bit later too in this course. Just because you think it's safe, you already know that it's going to be called out. Just say further evaluation from an electrician, let them deal with it. That's what they're trained to do. Now, however, some inspectors may choose to go beyond the standards of practice because they suspect some sort of defect or whatever. They might actually really want to try to perform a fuller inspection or information to their customers or clients, and that's fine. Just know what you're doing when you're doing it. Don't just do it because the realtor tells you you have to. Say, I don't feel safe doing that. I'm not going to take off electrical outlet covers. I'm sorry, I'm just not going to do it, and that would take forever. I'm sorry. Once I get into that, I'm not going to be doing it. Now, um, sometimes realtors might persuade you to do that. Well, I suggest that you talk to them about it. Okay. Now, panel board clearance. This is probably one of my common call outs that I do at almost, I would say probably at least once or twice a week, just because people will put shelves right dead straight in front of the panel or right beside it. They don't have the clearance that they should have. Sometimes I find them in kitchens. I mean, it's just crazy. And there's a refrigerator right there. I don't know, whatever. But panel board clearance, the electrical panel boards require adequate working space. This is very deadly equipment here, and people don't even respect it. So that's why the general rule is 36 inches of clear working space in front of the panel, 30 inches of width centered on the panel. So right from the center is 30 inches. Okay. And it should be 6.5 feet of headroom in a working area. Okay. Uh, Panel board should not be located in bathrooms. I can't tell you how many times I've been. Actually, I went to a remodel, and the panel board was in the bathroom in the remodel, and it passed the inspector, the city inspection. So, and I said, you're not allowed to have this in the bathroom, right? Oh, I didn't know that. Huh, all right, whatever. You don't want it in closed closets. It used to be very common in closed closet, but because of the fabric and the dust that it creates, it's not a good thing to have. You don't want them in toilet rooms. You don't want them over stairways. I can't tell you how many I've done over stairways. And breakers must remain readily accessible. You have to be able to get to a place if there's a problem. That's the whole point of having that, so that you have access to shutting off that electricity. There is something I call out frequently during these inspections, especially when storage, the shelving, the water heater sometimes, um, all obstruction of that panel. And like I said, about twice a week, I call this out on a regular basis. So I, it's just something now it's actually a pet peeve of mine. So the other thing is that you want to make sure that things are labeled. Now, I don't expect anybody to go through and make sure that that is properly labeled. Okay, that takes a lot of time and effort. And for the most part, I look at it, make sure that it kind of sees or kind of fits what it's saying. So some like you're not supposed to have like microwaves should be on their own separate circuit, things like that. If I see a microwave, okay, I'm good, and kind of leave it at that. If there is a spare or unused breakers, you might want to put that in your report. Labeling such as lights, plugs, or bedroom are often too vague and you don't really know what's going on. So incorrect spelling or illegible labeling. Do not label this with pencil. Now, I remember that on tool time. Don't label in pencil. And everybody who knows what tool time is, I think you should get some extra credit for that. Um, so there's always going to be someone that's going to probably work on your electrical at some point. So it's always good to know that things are labeled and it's good to know that they're labeled correctly. I got two, the AC and the dryer are labeled incorrect on my panel. And I know it. I have never fixed it yet, but I'm hoping to get a whole new panel before I do that. But I know. So this is another item that I frequently will call out on a regular basis because things aren't even labeled at all. So they're like, you really should have this labeled uh, just for your own sake. And if you own a house, please just go through and label it. So electrical shock hazards. Electrical shock is possible anytime power is present, regardless of the voltage or system devices. Uh, Typical electrical circuit has a conductor that delivers power to the load and the neutral conductor that returns the current to the source. And that completes the circuit. You remember in third or fourth grade, whatever you did when you took the battery and you hooked up the light, that's exactly what's happening. But this is a much um, more electricity in a house versus just a 9-volt battery or a 1.5-volt battery. Most residential circuits operate at approximately 120 volts and they carry either 15 or 20 amps. That's enough to really jolt you. I can't tell you how many times I have been jolted because I thought I turned off the breaker and I didn't check it. You do it 2 times, you won't do it again. So always assume conductors are energized until you actually prove it otherwise. So take your little meter and just make sure that it is not energized. I normally carry one of those meters with me when I go into attics too, because a lot of times I will find stray wires and I just want to make sure that they're hot. Or sometimes I'll go to knob and tube and they're like, oh, all the knob and tube has been redone. So I'll just, check it. Oh, no, it has not. Well, guess who's getting a call next? That electrician that said that he did it all. So there you have it. Um, right here, some devices can hold an electrical charge even after the power has been off. Now, like, for instance, if there's a capacitor, like for your air conditioning unit, if you actually touch that and the power's been off, but you touch it, sometimes you will get a shock you would not believe. So make sure that even when you have the power uh, off, that it is completely off, and make sure you double, triple check it if you have to. I want everybody to be safe. That's bottom line. Just be safe. There are warning signs that a panel board or cabinet or box or the system in general may be compromised. I just went to a place that said um, similar to the warning saying this has been looked at by a professional, blah, blah, and it had like the red flag on there. And I was like, what's this about? And the guy says, oh, yeah, they had to shut off the electricity. They had some issues, and the current homeowner actually had it all fixed, and they didn't take the things down. So there was nothing that I saw wrong with the panel board after I took it apart. So we're all good, and they got their 4 points, so that was good. Anyways, an inspector should defer anything to a licensed electrician. So if you see, scorch marks, if you're seeing rust, even like I just called that out a couple days ago there was rust on the panel board. I just want to make sure that the customer knows that we're looking at it. And so I just make sure that I continue to do what is right. Overcurrent circuits, a lot of times I'll see that on air conditioner. It'll say 25 amp max, and then there's a 50 amp circuit breaker for that, and that's not good. You should actually have 25 amps max. So I call that out quite a bit. Any signs of water inside the panel, you don't really want to even open that up if that's the case. Uninsulated wires, you see that quite a bit, and you can't call out everything because sometimes you can't see it, but try to make sure that you call out as much as you possibly can when it comes to electrical safety. The panel board, it might actually have a buzzing noise. A lot of times I will ring the doorbell, but I don't see the doorbell. Sometimes I'll put that doorbell inside the cabinet, and that's another no-no, and that could be the buzzing that you heard too. I've also had it where circuit breakers did the same thing, that they were buzzing. When I did my thermal camera, I used like this little thermal camera here, take a picture of it, and sometimes that'll be like the hot area. It's like, oh, okay, yeah, I don't want to touch that. So there you go. According to the InterNACHI standards of practice, the inspector must report any unused circuit breakers panel opening that is not filled in need of correction. So make sure that if you see that blank spot, you are referring that as it needs to be corrected. Refer to the illustration below here, that the little panel um, plug there, basically it is. I'm trying to blank what that's called. Ah, doesn't matter. The 2021 IRC section 3046 refers to unused openings in electrical components, including the panel board, unused openings in the panel board other than openings for mounting purposes or special equipment. So I always call those out too. A lot of times, like especially here in Florida, if you have an outside panel board open and then you have that little knockout, that's what I'm thinking of, knockout cover is missing, you must get a knockout cover for that. And the reason why is because I can't tell you how many fried geckos I've seen inside electrical panels as soon as I take that off. Well, like, or wasp nest. That's even the worst one. Taking panel board off and there was covered in wasp. Just put the panel cover back on nice and slow, and I got the heck away. Matter of fact, I didn't even take a picture of it. I wish I would have, because that would have been a great YouTube video. Anyways, knockouts should be covered in all those openings. You don't want anybody sticking their finger in there. You don't want animals making there. You don't want snakes. I've seen rats inside. I've seen a lot of stupid stuff that get inside there just because openings. But when you don't have that cover over the slot where the circuit breaker is, you want to make that's a no-no, because somebody could stick their finger in there, and I'm sorry, you're going to be having a funeral if they do that. So you don't want that. Um, so cover all those openings. Make sure that they're covered. Make sure that you put them in your report. And, if anything, further evaluation from an electrician if you're not sure. So this section is not intended to be applicable to the hole provided for fasteners for mounting purposes. So when you're hanging the panel board, those little tiny holes, and not such a big deal. The big knockouts where you can stick your finger in, big deal. So make sure that you're calling that stuff out. An arc flash. No, this is where it gets scary. And I'm not going to lie to you. Uh, this is probably one of the scariest things that can happen during electrical. Matter of fact, Thomas Edison and Nikola Tesla were fighting about if they should go uh, AC or DC. And so Thomas Edison showed that you can electrocute somebody in the electric chair. And now we have the electric chair because he was showing how dangerous AC current was. But arc flash happens when it leaves the unintended path and travels through the air or to another person or whatever, and then goes right to the ground. It often happens unexpectedly and can explode. But in brief, it's a second. And it's like a firework, honestly. It can cause little damage or it can disable an entire system. An arc flash uh, of any size is dangerous, no matter what it is. Matter of fact, I went to a house to do a expert witness from some people that were installing solar panels and they caused an arc flash, and it was not a good sight, that's for sure. The whole thing was just, I mean, it looked like somebody threw a dynamite on the wall and it just boom. So cool, but not cool. And those temperatures can, I believe, 35,000 degrees in 1 second. So everything in the panel board just goes to a gas instantaneously and then hits you again out. And it's just not good. So when you're taking off that electrical panel box, make sure that you're holding that dead front cover in front of you. So if it did explode, at least your fingers might get it and a little bit of you, but you're not going to hit that whole blast. So that's what it is. Approximately over 400 people die each year from arc flash related incidents in the United States. According to several industry standard studies, the Electrical Safety Organization, of course, more than 2,000 workers are treated in burn centers annually for arc flash injuries. Arc flash incidents occur an estimated 5 to 10 times per day in the United States. So it is very serious. That's why I say if you feel like you can't do something, don't do it. Safety is number one concern here. You can also get things from InterNACHI, I believe, like this sign here, inspector at work, stay back. You want to assist your risk tolerance. Do not no, you are not required to perform an invasive electrical inspection. Remove the dead front cover of any electrical panel board that exceeds the InterNACHI standards of practice. So get to know the standards of practice. Even if a home inspector is highly confident of their technical training as well as their situation, he or she can also confirm that the system is de-energized. Any suspicion, problem, whatever, make sure you disclaim it. Okay, wear your PPE. Regardless of whether you're new or you've been in this for a while, you really should be wearing protective goggles. I can't say I do it every time. You should be wearing gloves, insulated gloves. Even the garden gloves are better just with the rubber on there. Those, it just helps so much. And like I said, I don't always do that, but I do it um, quite a bit. Even a, sorry about that. Um, even a small spark can actually cause a lot of problems. Check your surroundings. Make sure that there's if there's a lack of ground fault circuit interrupters, things like that, you want to just make sure that you're staying safe. So the service entry cable, the blue arrow, is line of service conductors. The white arrows, um, I just totally lost my place there for a second. It's located between the terminals of the service equipment, the main disconnect. At a point usually outside of the building, clear of building walls, of course, and where they're joined by a tap or a splice, the orange arrows there to the service drop or overhead service conductors. Those are the red arrows. The blue arrows is pointing to a protective or sheathing, the SC, the service entry cable. The service point is the point of connection. Those are those orange labels right there, or arrows, between the facility of the service utility and the building wiring. The overhead service conductors, those are the white arrows. These are also the overhead conductors between the service point, the orange arrows, and the first point of the connections, which is the service entrance conductor. Those are the blue arrows. We're going to kind of go into this a little bit more. It is understood that those are the raceways. Whenever you think of the raceways, I want you to think of the current flying through there, through the conduit and stuff like that. Those are nice raceways. The fitting and enclosure housing service conductors are also part of that service equipment. The meter socket and the enclosures are not considered service equipment. Meter enclosures do not have interrupting ratings. So disconnection means or overcurrent protection. And if you ever go to a meter, you will know that the only way to shut that off is by pulling that off or contacting the utility company to shut off it at their hub. The red arrows point to the service drop. So that's considered the service drop that is coming in from the line overhead. Okay. The white arrows are also service conductors. They are referred to as overhead service entrance conductors. Okay. The important common used term for home inspectors are overhead service conductors. That's basically all I put in my report. Those are the red arrows. The service entrance conductors, the white arrows and the blue arrows, and the splice, the orange arrows, I kind of just leave those out. I just make sure that they look like they're in good shape, so on and so forth. So that's pretty much it on that. The SE, which is service entrance, you hear that quite a bit. The cable assembly is designed with a high degree of resistance to mechanical damage and the sun's ultraviolet light. So, for instance, it's one of those things where, especially like here in Florida, that sun is hot, and for that reason, it is not insulated in a conduit, but it's attached directly to the building, so it doesn't overheat. If it's located someplace where it's likely to be subjectly physically damaged, like car doors, etc., it has to be in that conduit, and it should still feature a gooseneck, of course, and a service head cap. And the end where the individual connectors exit the sheathing should be protected from moisture intrusion, of course, and by the heat shrink sock of the gooseneck, because you want to make sure that everything is nice and solid and connected together. I kind of think of it like your body all one unit. Same thing, you want it all to be connected into one unit and make sure that it's sealed so that, you know, bugs and pests and rain can't get in there. So the type of cable should be attached to the building every 30 inches along its length and within a foot of the top of the meter can. So make sure that you kind of check that. And you can eyeball it. I mean, it's not like, you know, if it's 30, 30.5 inches, oh, I'm going to call this out. You know, don't be that big of a stinkler on it. Okay. The SEU is the unarmed service electrical three-wire cable with two conductors and a neutral. The SEU typically has a stranded neutral conductor that wraps around the cable to create an oval shape. The SEU cable has a neutral conductor but does not have a grounding conductor. Since neutral conductors and grounding conductors are connected at the same point of service disconnect, the SEU cables can only be used up to the service disconnect to avoid significant safety concerns. The SER is the round service electrical four-wire cable that typically has up to four connectors and a bare neutral. The cable is designed to be used in feeder panels and branch circuits. The SER cables are equipped with a neutral and grounding conductors, which makes them perfect for use after the service disconnect. The image above here shows a 200 amp panel board supplied by a four-wire SER where the main service disconnect is installed at the meter outside and the additional disconnect there is installed at the panel board, it looks like. So should be, hopefully everybody understands that. The service entrance conductors. Service entrance conductors are typically made of either copper, aluminum, or aluminum. Aluminum conductors must be larger than the copper. We've already discussed this. That's so that the resistant factor of the aluminum uh, kind of uh, dissipates that. So you're basically, yeah, we've talked about it. So the AG, there the AWG is the American wire gauge, and the standard among, and you can look at this chart. We've kind of discussed this already. If you want to do a screenshot of it, it's actually good to know just so that you kind of keep it in your head and go from there. So I'll give you a few seconds here. Conductors larger than the 4 gauge wire are typically sized using the KC mills, which represents the conductor cross sections area in thousands of circular mills. So there you go. Most homes in North America receive a 120 to 240 volt split phase power from the utility through either the overhead mass or underground lateral. The system consists of two 120 volt underground conductors. Those are the hot, okay? Whenever you say ungrounded, it means that, oh, I'm not grounded. That must mean I'm hot, okay? So a lot of times people get that confused, especially like when I'm mentoring other inspectors, they don't understand that ungrounded conductors are hot. So just kind of keep that in the back of your head. Each hot conductor provides 120 volts to the neutral, while the two hot conductors together provide 240 volts. So if you put those two together, you got 120 equals 240. So most of your lighting and things like that throughout the house are 120 volt. And then the larger appliances, you already know, like your water heaters, your ranges, your dryers, things like that are 240. Air conditioners, of course, and electrical furnaces too. The neutral conductor originates from the center tap of the utility transformer and serves as the return path for the 120 volt circuits. While all neutral conductors are grounded conductors, not all grounded conductors are neutral. That's why when you're doing electrical inspections, that's why the sub panel has to be disconnected from, or sorry, the grounds have to be disconnected from the neutrals. Most homes in Europe use a three-phase electrical system, which allows multiple homes to be supplied more efficiently from the same distribution center. Things are a little bit different when you get over into Europe. The same rules apply though when you're talking electrical. So electrical services refers to conductor is the equipment that delivers the power from the utility to the home or the main service panel and the main disconnect. Power is typically supplied by three conductors entering the home either overhead or underground. We all know this. Overhead conductors are called the service drop. So make sure you keep that in your head, which that should be connected to a weather head and travels down to the service mask into the electrical panel. So got a couple funny stories I'd like to share, but we're going to keep going. So power comes from the utility onto two hots and a neutral, enters through the weatherhead service mask, passes through the meter, and ends up in the main electrical panel. As inspectors, we're looking for proper clearances, secure attachments, and any signs of damage and wear. I can't tell you how many times where I've been to places where I've actually seen sparks coming from right where the transformer is and called it out. And, you know, a realtor was pretty mad, but hey, it's safe. Or even the telephone pole or the electrical pole is actually leaning. I want to call stuff like that out just to make sure that who's ever, I just want safety. That's the biggest key here. And we want to make sure that everything that we do is safe. So here on the service mask, we're talking about the how it's dropped. It typically is located above the eaves. The mask or riser is run through the eaves or when run underground from the utility pole to the electric meter, a lot of times you'll see that big green box in their yard. It's probably going from that big green box right to the electrical panel from there, the service conductor or whatever, or the service panel. The service conductors are installed in buried conduit or runs as the underground cable goes through that. The illustration below shows the main components of the common underground service installation, including the meter service panel, and the grounding electrode conductor. So you can actually see how things are brought in, goes to the transformer, goes down underground, and then into your electrical meter, then into your service panel. There you be. Residential electrical services. Again, we're going to talk about this again. Most homes are 120, 240 split phase service, and the service consists of two hot conductors and one neutral conductor, which hot provides 120 volts, or each hot provides that. So you get 110 or 120, 120, you get the 240. While both hots provide that, the neutral is the return path. It's electricity always wants to find its way home, and the neutral provides that for it. Uh, and it's always to go back to that transformer. Now, not the grounding conductor, but the neutral. The hots terminate at the main breaker, and the neutral terminates at the neutral bus. For a deeper understanding of the grounding electrical, please check out that Electricity 101. President, we did it through InterNACHI. You can check it out. It's right there on YouTube. You'll learn a lot about it. Electricity 101 and 101 Part 2, grounding and bonding. There's a lot of information there. Mike Holt actually has a really good bonding video out there too. So, and grounding. Service drop and point of attachment. You're going to see in this, in the very left image here, the service conductors are connected with a crimped connector protected by an insulated sleeve. The center image is typical service drop with two hot conductors and one neutral conductor connected at the weatherhead. The right image is missing insulation, and I've seen this actually on the service entries there. Oh, yeah, definitely call it out. Make sure further evaluation from an electrician right there, right away. Inspector should verify that point of entrance or the attachment to, and the service conductors are properly supported. Um, I still can't get over that picture. And the service drop maintains at least 10 feet of clearance above grade. So no little kids are gonna sit there and play with it. Went to one house in Minneapolis once, and it was her service wires were right over, literally above the door where you open it up to get into the house. And she said, "Oh, every winter should knock it off to get the ice off there." Not a good place to be. The service drop clearances. That's why we have these codes in place. Just because a service drop has been there for 30 plus years, it doesn't mean it's safe. If someone can reach and touch it from a balcony or window or whatever, it's worth a closer evaluation from an electrician. Inspectors should verify that overhead service conductors maintain proper clearance from roofs, decks, balconies, so on and so forth. As a matter of fact, I went to a 1910 house, and the service drop was 7 feet from the ground. Yes, I called that out, and the realtor never used me again. Oh, home additions and renovations, such as decks and balconies, can sometimes place service conductors within reach. Make sure you're calling that stuff out. That left image there is a second story deck um, uh, that reduced that clearance for that overhead clearance there. Wow. In the right image, that guy can just pull that down, and yeah, it's not good to be able to swing on those, just FYI. And you probably don't want to either. You don't want to be a bird on the wire. Anyways, when inspecting overhead service conductors, remember these common rules. 18 feet over roads and truck traffic, 12 feet over driveways and residential property. 10 feet over sidewalks, decks, balconies, and walking surfaces. 22 and a half feet vertically and 10 feet horizontally from swimming pools. 3 feet from windows and doors and porches and balconies, so on and so forth, and 8 feet above from flat roofs and 3 feet above pitch roof. You never, ever, ever want to touch those wires. As an inspector, we often find additions and decks and balconies and things like that. Just call them out. As far as pools, I honestly haven't seen any wires over a pool. Maybe you guys have. I have not. Uh, but just remember that's 22.5 vertically from that pool. Here's another image here that kind of shows it. A lot of times, I have this in my report so that people can actually see it. And that's the cool thing about InterNACHI. They do have a lot of these visuals that you can use as long as you're an InterNACHI member or you get permission. So the goal is simple: keep electricity far away. Accidents do happen, and we want to minimize those accidents as much as possible. So another common clearance problem is trees and shrubs and things like that. The overhead supply, the electrical, or sorry, uh, the inspector really should take time to eyeball these things. If you see a lot of trees and stuff, and I've called this out too, and again, I've had realtors get mad at me. Oh, why'd you do that on the electrical? Well, call the electrical company, have them come out and cut the dang trees back. I don't care. I'm just telling you what I see. I'm sorry I see it. But that's what we're hired to do and be um, neutral on everything. So I don't care if the house sells. I really don't. I'm just telling you what I see. Also remember that the branches are heavier during the summer and weighed down further. So, and yeah, just call the stuff out if you see it. The inspector should recommend at least limbs be about 5, 6 feet away from those cables. Just kind of a general rule. So, and so here we got a drip loop here. Um, And the service mast carries the overhead power into the home. We all know that. The mast head, the gooseneck, helps water stay out and kind of protects the conductors. The drip loop, now I see this a lot, especially when it rains a lot, that helps keep that water um, to flow off that. Matter of fact, I was putting up some lights at our house, and my wife's like, "What is that?" And I'm like, "It's a drip loop." She's like, "Why do you have a drip loop?" Oh, let me explain. Oh, she goes in the house. Really, she didn't want to hear. Couldn't believe it. But this allows the water to drip off those conductors. So even if you're hanging up your Christmas lights, things like that, you use that. It works very well. Inspectors should look for damages, loose fittings, anything that looks outside the normal. Make sure that you're calling those out. Missing those drip loops. I've seen it where um, they forgot to put them in, and it just goes straight into it. Like, that's not good. Yeah, not good. Um, Service mass for supporting, you want to make sure that you are looking at the surface drop and the overhead service conductor. The mast uh, should be at least 3 feet above the roof line. It should be well supported. The weight of the cable assembly and consider it, make sure that you're keeping an eye on this. If it's leaning too much, if cables are broken, it's common to see telephone cables and TV cables, satellite dishes, clotheslines, things like that. Um, it just the overhead service mask must not support such things. So you really need to look at this and say, yeah, that's not really designed for that. So the IRC is silent on the size requirement and conduit type to be used for the mask or the riser. It's also silent about height above the roof. It can extend before being supported by braces or guy wires in many jurisdictions. You might want to just kind of look uh, where you're actually inspecting. The mask mount flashing or the service mask flashing, as with any other projections through the roof surface and anything, it does require to have adequate flashing. So check to see if there's any type of flashing around there. Make sure that it's sealed nice. If you can look inside the attic, if you can get into that little area, it would be really great, especially like if you look at that left um, corner picture, you might be able to see right up from the soffit there if there wasn't a soffit there, and you can see if there's leakage and stuff. But the surface mask attachment, you want to make sure that the mask is a clamped within like 12 inches of either side of the meter base. As well as the top of the mast too. You want it on both sides. It is way too common to see the attachment clamps not replaced when they're rusted out. I've called that out a bunch of times. Just be visual. Take your time. The way I do my inspections is up, down, and I take 4 foot sections. Even when I'm doing electrical, I make sure that I spend a few minutes there just looking. I want to try to get any defects in there, and just say further evaluation from electrical contractor or a licensed electrician, however you want to word it in your report. Many newer homes receive power through an underground service. This is really common nowadays. There is a few things that you want to just make sure while inspecting these areas. You want to make sure that the underground connectors themselves are generally not visible. So if you do see them visible, make sure that you're calling that out. Matter of fact, my kids were digging in the yard and they came across the cable, and I'm like, honey, I told you not to have kids, I told you not to dig in this area. There's a reason for it. Dad, we found a cable. Duh, you're lucky you're still alive. Kids. Underground connectors, the UF cable is approved for direct burial and is designed to resist moisture and soil conditions. It is typically buried about 18 to 24 inches deep, depending on the jurisdiction, of course, and installation requirements. Even direct buried cable should be protected by conduit where it emerges from the ground and enters into that house. Visible underground conduit should be made of galvanized metal or gray electrical PVC. You'll see that quite a bit. Conduit rated for underground use. So make sure that if you see um, anything outside the normal, just defer it out. It's really that simple. Where the service cable is not rated for direct burial, it needs to be fully in conduit and must be buried at a minimum of 18 inches under landscape and 24 inches under hardscape, such as like driveways and things like that. The left inspection image here shows a commercial building electrical service, and basically that's what it should look like. Nice straight even lines. The residential construction where they're you got it coming up from the ground into the conduit and then into the meter base. That's exactly what we kind of want to see. Above ground connections, if you see anything that looks outside the normal, things that are come apart from the house, things like that, call that stuff out. The bottom middle image there shows a typical service lateral riser. The top right image is of a damaged conduit. Just call that stuff out. If you see it, say something. I don't know if you guys remember that, but if you see it, say it. Electrical meters and meter bases. The electrical meter measures the amount of electricity used by the property and is not considered part of the service equipment. The meter base is the enclosure where the utility installs the meter. Depending on the house design, the main disconnect may be located in the main panel at the meter base or in an exterior disconnect enclosure. When the main disconnect is separated from the panel, the conductors running to the panel are called feeders. Okay. I was going to say something here and I can't remember what I was going to say. So we'll just keep moving on. These are pretty cool. The round meter bases were typically 1920s to the 1950s, and you'll still see these every once in a while, and it's just history right there, right in the open. So uh, normally, if I see something that's that old, I just kind of leave it. That's on the utility company. It's really not on us whatsoever. So, but you might want to say for their evaluation from, you guys know the rest. As meters have increased in capacity over the years, the meter bases have changed. So you can actually see different meter bases from the earliest meters, such as this one here. Understanding the meter base is an important part of being able to properly evaluate the maximum availability amperage of the home, believe it or not, but should not be relied on completely when sizing the service. Okay, so here's some other ones here that are all rounded and just, I remember these as a kid. It just brings back a lot of memories. I remember the dryer. My mom would put on the dryer and would sit there and watch that needle just move. It was like, wow, what's that? It's the little things in life, right? We got two more images here, the round meter bases, and then a couple electrical panel boards there without a cover on it. I would recommend put up a cover on it. Further evaluation from you know what. Grounding and bonding. This is one of the most confusing topics, and that's why I did the Electricity 101 grounding and bonding course, or sorry, the webinar. Grounding connects to the electrical system in the earth. It helps dissipate lightning strikes and voltage surges. Bonding connects metal components together to provide a safe path for the fault current and helps breakers trip quicker during that fault. Most homes have a grounding electrode system that may include ground rods, metal wire pipes, or concrete encased electrodes, otherwise known as OOFR. I believe that's how you say it. If you want to dive deeper into this, check out that Electricity 101 presentation by InterNACHI. It was great. I did it, and I think we got really good results from it too. This is really critical because it helps um, diversi diversify a lot of that electrical system if there was a lightning strike or a voltage surge, and it helps it get to the transformer faster or to the electrical panel faster. And if a grounding rod, pipe, or plate electrodes are used, they must have a rating of at least 25 ohms or less. Otherwise, an additional electrode must be added. And this is all in the NEC 250 area, and I believe it's 250/56, I believe, but I could be wrong. Um, a grounding rod is footing reinforced steel. Normally, it is copper. And the metal underground pipes, examples of this system all grounded together or bonded together, I should say, which are medically electrical or metal metal electrified, electrically connected together through these terminals, and it all goes right to the earth. So you can see right there how things should be bonded together, even through like your water heater there. And if these are all metal pipes, just FYI, you don't want to ground plastic pipes. It's just kind of silly if you ask me. But I have seen it done, believe it or not. I saw a clamp on a PVC pipe and went to another PVC pipe. I'm like, that is brilliant use of nothing. So there are several methods of connecting the ground system to the ground, which are driving the grounding rod right into the ground is the most common. Most residential construction requires two separate grounding electrodes in combination of the following, which needs to be at least 6 feet apart. You need driven rods. Rod typically grounded electrodes are the metal water pipes, the well casings, the UFR grounds, the grounding plates, the steel framing, and grounding rings. And a lot of times you're not going to see grounding rings or the uh, grounding plates, just FYI. Historically, the grounding system had just one connection to the ground, and it was nearly always made on the water pipe. Now, however, with new jurisdictions, most jurisdictions, um, to ensure a low impact or impedance ground, one with a little resistance. So because most utility companies now install plastic pipes, like I've said, water lines, they're not to be grounded or means of grounding anymore. So a lot of times, like uh, your well casing is still metal, and that can be ground. That could be a system to ground, or um, you know, anything that's metal in the ground basically could be a grounding wire. Now, gas piping should not be used as grounding electrodes, just FYI, for safety reasons. But in most areas, gas lines are required to be bonded to the grounding system. If they are likely to become energized, we want a place for that energy to go. And again, check out the NEC 250 area that is all about grounding and bonding. So there you go. This is what a grounding rod actually kind of looks like. And pounding on the ground is sometimes a pain in the tuchus. But grounding rods are typically about 5/8 inch diameter. They're made of copper or galvanized steel. Ground rods are uh, ground rods and a pipe electrodes must be at least 8 feet long and in direct contact with the soil. If rocky conditions prevent vertical installation, ground rods may be installed at an angle of 45 degrees or buried in a trench at least 30 inches deep. The top of the rod should be flush with the with that grade. So that protects it from being damaged. Ground rods should be corrosion resistant. They should be properly coated or galvanized. As inspectors, a grounding rod stick out of the ground is a defect and should be reported. Now, I know like if it's like 2 to 3 inches off the ground, typically that's what they're saying here. And yeah, that's what they're saying. Grounding electrode connections. The grounding electrode conductor must be secured with an appropriate clamp. I've seen different people use hose clamps. I've seen them put the wire on the wrong side. I've seen that just weird stuff. These are acorn clamps. They're commonly installed incorrectly. I've seen it 1,000 times. Like, oh man, who put this on? But when it's not supposed to be underneath that, just I don't know, whatever. Let's not go there. When a metal water pipe is used as a ground electrode, the connection must be made within the first 5 feet of where the pipe enters the home. Because water meters can be removed, a jumper wire must be over that water main. And you can see the jumper wire in that illustration right there. And again, something you should be looking at, especially if you see this quite a bit. And I do a lot of new construction, so I don't see this too often anymore. Kind of sad. Kind of miss those old houses. So that jumper wire is um, definitely something that you should be looking at. They should be, for example, a jumper wire may be installed over the water meter because the continuity of the grounding path or bonding connection of the internal pipe should not rely on the water meter. And it could actually blow out that water meter too. So the jumper wire is a large gauge conductor that jumps from the water meter and is securely attached to the water or the metal pipe on the other side. So it just jumps over that. So, and not shown here, but I already talked about the well casing too. It has to be within great depth, and you can actually use that as a ground too. So, um, here we're talking uh, about more grounding, and the more popular. Uh, what am I looking at here? I forgot. So with so many homes, and commercial buildings now built on concrete, steel enforced slabs, this grounding system has become very popular. So requirements for the roof or ground are that they have either 20 feet of number 4 rebarb or a 4 AWG copper wire embedded into at least 2 inches of uh, soil concrete, which within the footer and so on and so forth. So this system must also have an external means of connecting other ground systems to it, such as like your telephone wire. I don't even know why we have telephone wires anymore. But normally like your high speed internet, things like that. So we want to make sure that it can be um, conducted there. And I just want to say that these images were provided by InterNACHI member Greg Pretzwell, shown both the rebarb in place prior to the concrete pour. Thank you for being able to share that with us. The rebarb is painted green, so it is present, can be verified really easy with local inspectors in that area. So other grounding electrodes, you got your grounding plates. They're uncommon in residential construction, but you can see them every once in a while if you do commercial buildings, but must be at least 2 feet square and buried at least 30 inches deep. The steel frame buildings must use a structural steel as a grounding electrode when properly connected to the earth. Ground rings are rare in residential application and consist of two gauge connector or conductors buried at least 30 inches deep around the structure. This is all good information that all inspectors should really actually just know and keep it in their back burner. I feel like we've seen that glove before. Grounding electrode conductors, which is the GEC. The grounding electrode conductor connects the electrical system to the ground electrode. The GEC is typically made of copper or aluminum and normally does not carry current except during a fault. And that's exactly what the ground is all the grounding wire is supposed to do. A ground rod sticking significant above the grade is considered a defect. That's what they say. A lot of times, if I can just see it, a lot of times, lately, all I see is they have the cover over it, and then you look down to the ground, and it's actually below the grade. Um, in the image to the right, the home inspector is looking at the upper end and calling that out as a fault. So there you go. The 2023 NEC now requires surge protectors on new replacement dwellings, service equipment. Article 230 .67 requires protection, while Article 242 covers the installation requirements for surge protection on devices. And you can read that if you do have an NEC 2023 NEC. I always carry that with me. Most surge protectors are connected to a detachable 240 volt breaker and should not be double tapped into existing breakers, just FYI. Most units have an indicating light, so you can see that it's working or not. I do recommend that when you do these inspections that you are testing those to make sure that they are working. As I like to say, it's a lot cheaper to replace a surge protector than an air conditioner, refrigerator, television. Some of those televisions are getting pretty spendy, and computer, of course. So you definitely want to have surge protection, stuff like that. Um, anyways, got off subject there for a second. The purpose of bonding is simple: is to provide a path of um, to provide a safe path for fault current and help breakers trip more quickly. We've said this before. After the main disconnect, grounds and neutrals must remain separated. So as soon as you look at the main panel, every single panel outside of that should have the neutral and the ground separated. We want to have them married in the main and divorced in everything else. So other metal components that should be bonded includes the water piping, the gas piping, the water heaters, the CSST piping, electrical enclosures, the raceways, telephone cable systems, things like that. Bonding helps ensure that metal components become, if they become energized, they have a place to go. And the breaker trips instead of the metal remaining energized and causing someone to get shocked. And if you get shocked, it doesn't feel the best. I'm just letting you know. The main bonding jumper wire, this is the main service disconnect, the two hot conductors connect to the main breaker, and the neutral conductor connects to the neutral bus bar. That's the main jumper, and you can see a picture of that right there. And yeah, some other pictures here that were you can see the pictures of the MBJ screw installed at the top right corner there. You can also see the factory installed there at the bottom. And kind of keep an eye on that too, because sometimes you'll see in the sub panels that you'll see that jumper, the main bonding jumper wire connected where it shouldn't be. And the inspector images show several styles of panel board bonding. Some are straps and some are screws, and you can see the little burn there on that one screw. Well, it's because it got energized and it had a place to go. So that's actually good. And if you do see that, maybe you should put in your report further evaluation from you got it. So in more modern panels, the bonding connector is required to be through an approved green screw. So it is more apparent to both the electrician and the code enforcer, and of course, us home inspectors. In the service equipment, and only in the service equipment, just like the main electrical service panel above, at the location of the main disconnect, the grounding service conductor, the bare stranded neutral conductor in that illustration, is connected to the same neutral bus bar. They have to be married right there. So the job is simple, but it is critical to provide a low uh, impedance path for the fault current, allowing breakers to trip when they need to trip. And it also brings electricity back to the transformer if it was very high. A simple rule is bond once and only once at the main disconnect. So just marry them together right there. At the main disconnect, the neutral and grounding conductors are bonded together and connected in the panel. I feel like I want this drilled into your head. They get married at the main and divorced everywhere else. So everywhere else, the spouses are sleeping on different rooms of the house. So if you can remember that, they're married here. This is the main house. And guess what? Inside the house, they're sleeping in different beds. So that's a good way of kind of remembering it. The sub panel, again, the it contains your service panel contains that main disconnect, and everywhere else is your sub panel. The sub panel is any panel located downstream the main service panel. And in the service panel, the neutral and grounding conductors must remain separated. I keep saying that it's disconnected there. The only exception to this is existing attached structures with no metallic path exiting between the structures. So in this exception, a connection between the ground and conductor and the metal case via bonding jumper is permitted, according to that 2008 NEC. This is not allowed in new construction, just FYI. So in many cases, a 4-feet wire to the detached structure is required to order to isolate the ground conductors from equipment grounding conductors. So things have changed over the years. So just be alert of this when you're calling things like this out. In any case whatsoever, make sure that you are further evaluation from an electrician if you're ever stuck on something. There are two paths for providing ground conductivity back to the service panel. The four you can read this yourself here. The 4 conductor feeders with 2 hots, ungrounded conductors, or 1 neutral or grounding conductor. The 3 conductor feeder, and this is all part of the 250. Any grounding is in the 250 NEC. So anytime you have any questions with the go to 250. Just remember that. It's an important note, every structure is required to have a grounding electrode system. If there are present in the structure, there must be bonded together. If detached structure has a remote distribution panel located at the structure, then it's required to be grounding electrode system of its own. So there should be another grounding wire at a different area. It's also important to understand that if the detached structure is being fed by a single branch circuit and it's contained equipment grounding conductor that is used for grounding the non-current carrying metal parts of the equipment. So further evaluation, always further evaluation if you have to. The inspector should pay very close attention to the grounding and bonding of all electrical circuits. And I remember getting into this and it was like, man, I felt like I didn't know any of this stuff. And as you start doing more inspection, especially your newer inspectors out there, it does get overloaded. And sometimes it does get confusing. And that's why these electrical courses are so important. There is a video here with Charles, and you can actually take a screenshot of that and watch this later. And he talks a little bit more about the grounding and bonding training. And Charles does a really great job. I watched this one, and the panel board and the cabinet normally is called the electrical panel, the breaker box, the breaker panel. It contains bus bars. If you don't know what the bus bars is, that is basically where it's traveling. If you think about a bus, it has a bunch of students in there and you can put them in. That's why it's called a bus. And Residential in residential construction, the panel board and cabinet are typically manufactured as one unit. The panel size are typically 100 amp service or 200 amp panel. Normally about 40 spaces or so are common. If you see it overclogged, make sure that you're calling that out too, because too much is never good. Panel boards are usually installed near where the service enters into the house and is mounted to the structure itself. In basements, it's common to see panel boards mounted to the plywood to provide a solid backing so that they can actually um, mount it properly. Common in these are we've talked about this before, and I'm not going to go through everything here, but here are your basic terminology of your panel boards, your bus bars, your main jumper wire. You want to make sure you're looking at all this stuff. And if you want to take a screenshot of this, there's only one location in the electrical system where neutrals and grounds are bonded, and that's the main panel. We've already had tons of questions about that. Typical 200 amp service commonly uses a number four aluminum conductors for the hots and a number two for the neutrals and so on and so forth. So just know the main lugs or terminals are the power that enters into the panel. So those and look at those, make sure that they're not burned or anything like that. You want to make sure that you shine your flashlight on there, make sure that it's not corroded or burned or anything like that. I've seen that quite a bit. All electrical connections should be properly torqued. And I don't expect you to put your screwdriver in there and make sure it's torqued properly. That is going way beyond the standard. And if you see anything, make sure further evaluation from you know. Okay. The main service disconnect now, or the main master panel or the master switch of the home, and that's the overcurrent protection device. It is typically located outside now, and it's where the service enters into the house. We want it on the outside, the main breaker outside, because if there was a fire, the fire department can go in there and just shut it off. It must be readily accessible and no higher than 6.5 or 6 feet 7 inches above the floor grade. So main breaker feeds the bus bars which distribute the power to the home's branch circuits. The person must be able to turn off the power to a house in the most 6 motions. So 1, 2, 3, 4, 5, 6. Boom, easy. Do not exceed that 6. The multiple service disconnect means should be grouped together and marked properly. Most electrical service have a single main service disconnecting means located either outdoors on the main load on the meter or an indoor panel board. So, um, lately, I called that out on a couple new constructions, and the jurisdiction actually said, no, we didn't do that here. So just FYI, jurisdiction overrides anything the NEC says. NEC is not law, it is code. And code means that it can be interpreted and it can be adopted and it might not be adopted. The neutral bus bars are typically striped of aluminum bored with holes to secure the connect wires, acting as the hub for the neutral wires returning from each circuit in the panel board, completing the loop of electricity. So it's going like this. Some panels may have just one neutral bus bar. Just saying, okay? Mine in my house has that. The ground bus bar. The ground bus bar serves as the central point of the grounding system. The main service panel is the only place where the grounds and neutral are bonded together. You've heard me say that all sub panels are separated. They're getting divorced. They can't be there. Circuit breaker panel boards um, look similar. They do the similar job, but they're mostly uh, feeding the house. That's their job. So these are probably the most common types that the home inspector should come across, and they have replaced fuse panels since the 1950s. In my opinion, fuses are awesome, but people have not used them correctly or put the wrong size in there. So breaker panels go further back than people actually realize. They actually were patented in 1910. However, it was unusual to see a residential breaker panel from or before 1940. Prior to this, electrical breakers were primarily used in manufacturing and naval applications. So breaker panels started appearing in homes in the mid 50s in small numbers and were universal in most areas in the United States in the late 60s. Now, circuit breakers did not replace fuses due to deficiencies of that older technology. The problem was that when a fuse blew, people would find a penny and put it in there or put something else in there that shouldn't have been in there and it wouldn't cause it to trip. Now, we have added benefits of circuit breakers like the AFCIs and the GFCIs, things like that. Circuits breakers actually fall into four different categories. It's the 1.2 or number one is the 240 volt double breaker. You got the 120 volt single breaker, and you got the GFCIs, and then you got your AFCIs. All of these requirements, some specialized knowledge so that you understand what's going on. Remember, we are talking about energized components. Safety is the primary focus. This is paramount in investigating any electrical devices, that everything needs to be put in. Here are some handle ties here. If you're looking at the handle ties, they're where two circuit breakers are together, and you must have a handle tie. So if one trips, they both trip. That way the system doesn't come energized, or one side of the system comes energized and the other side isn't. That's why you want those handle ties on there. Earlier, they used to make these handle ties that actually slipped right through the breakers, and you can see that on the green one there. That's why they have that in there, is because it just slipped in there. And if you look at the circuit breakers, a lot of them have that hole there still, so you can actually still use those, but they have to be in, eh, they have to be compatible with that system. So as fuses, the inspector should check that the rating of the fuse breaker does not exceed the rating of the conductor. Um, just FYI, there are two manufacturers of single poled 120 volt breakers who have their products listed for two conductors at once. So if you don't understand that, like if you're looking at a circuit breaker, it'll actually look something like this, and you'll have only one can go in here, but the square D and the Cutler hammer are the two that actually will have it printed right there saying that two um, conductors can be put in there. These are not to be confused with double taps, just FYI. And if you are confused about that, Further evaluation from you know what. GFCIs were found either in the panel or on the outlet itself. You can, and I always check these, make sure that they're working. If you push it and it doesn't trip, trip it and then come back because sometimes it'll break right there. So if you touch it and it doesn't, it just turn it off and then turn it back on. That way it still is a circuit breaker, but the GFCI is not working. Make sure you call that out as a fault. I recommend to my customers to trip them twice a year when you change the smoke alarm batteries. So that's kind of my thought. AFC breakers, kind of the same thing. I want them to trip them at least twice a year. These were in new construction since 1999. In addition to the NEC, many jurisdictions are now observing this as a required code addition, which have expanded use of AFCI's devices to almost everywhere in the dwelling. So these breakers are designed to trip if they sense a fault. So here's a brief history. In 1999, the NEC, these breakers were required only on bedroom receptacles. In 2002, they expanded to all the 15 amp and 20 amp circuits, single phase, of course. And later on, they developed into including hallways, similar rooms. And now it's pretty common to just see AFCIs on every single one of them. Again, they need to be exercised. So make sure that you tell your customers exercise these at least twice a year. Just trip them, make sure that they're working. Remember, the term outlet is not interchangeable. Just FYI with receptacle. Um, because outlets are defined by the NEC as the point of a wiring system. So basically a plug-in or current that can take different things. So they're receptacle. They take on, where you're looking at um, outlet, it is anything that's an outlet for a light or anything that's outlet. So the term outlet and receptacle are two different things. It is likely that many more locations, maybe even the whole house, will be required to have these NECs in new additions. Remember, every jurisdiction is different, so check with your local codes to make sure that you're doing what you say you're going to do. And you can also put that in your report too. A lot of times, like if I'm in a different area and I don't know the jurisdiction, I'll say some jurisdictions allow this to, and so on and so forth. So I just kind of put that little vague little thing in there for their evaluation from an electrician. Some jurisdictions do require this. So it's kind of the way I write it. The inspector should pay close attention to the following questions and report any defects as such. Does the breaker exceed the capacity of the conductor? Does the breaker have multiple incorrect taps? So those double taps. And I've seen quadruple taps. That's the biggest I've seen. Um, does the breaker have multiple taps? I just, wow, it's kind of funny. Does the 240-volt breakers have their handles tied properly? I've called that out, and I, yeah, I've went rounds with people before on that. Do the GFCI breakers test and reset properly? Like I said, twice a year, that's the way you do. Same thing with the AFCIs. You want to test them and make sure that they reset properly. Is there any signs of overheating? That's why I like to use a thermal camera, just to look at, make sure that the wires aren't getting really super hot. They are going to run a little hotter than the rest of their breakers because they are typically working. So if there's any signs of arcing or smoke damage or anything like that, you want to make sure you're calling that out. Electrical systems should require a means of disconnect. That's always something that needs to happen in any dangerous conditions whatsoever. Make sure that you're calling this stuff out. The service equipment is a necessary equipment. It usually consists of those circuit breaker, those switches and the fuses and all this stuff. And make sure that you're going through it and take your time. And if you have questions, you know, nowadays we have Chat GPT, we have other means of AI that you can always ask questions, and 99% of the time you'll get the right answer. There is that 1% chance that you won't. So make sure that you are double checking it. Sometimes ask those questions. And I believe we've had a couple of webinars on AI. So just FYI. And the main 20 or 200 amp breaker located uh, here is pretty common in most dwellings nowadays. So just check. A lot of times I'll take a picture of that too in my inspection report, say 200 amp um, breaker, so that the customer knows how to shut that off. There are different types of disconnects means, again, the rating, the fuse or the breaker or whatever, this relates to the total amperage within the home. If the main disconnect is, for example, rated only at 100 amps, it doesn't matter that the SECs are rated for 200 amps. Okay. The inspection photos above were provided by InterNACHI member Jeff Pope and Kevin Williams. So thank you for giving us those. And you guys can check that out. There's some really cool things. And that knife switch there, I got to say, is probably one of the coolest things ever. I always think of Young Frankenstein. That's where that picture was taken. And hopefully we don't get any copyright things there. But hey, it's still a great movie. Um, Mel Brooks, gotta love it. Here we got the split bus panels. And so there's two different buses on this switch or on this panel board or the panel. And you don't see these too often, but a lot of times, like if I see something like this, I just say further evaluation from an electrician. The split panel bar um, is just different. I've seen one or two, I think, in the 4,000 plus inspections I've done. So they're not very common, but you will see them every once in a while. This here is the a meter box, and this actually needs cover. You don't want to be able to stick your fingers in there or have an animal stick their tongue on it or something. You know, you don't want that. So you want to see main disconnect on the outside. Make sure that it is uh, good. For houses serving one family, the applicity of grounding service conductor shall be a minimum of 100 amps nowadays. A lot of times in the older houses, you'd see 60 amps. Things like that. That is something that I would recommend. You might want to upgrade the electrical system and put that in the report. According to the home inspector standards of practice, the inspector shall describe the main service disconnect amperage rating if labeled. That's all a home inspector needs to do here. Reporting the disconnect amperage rating is important for two reasons. First, an older home may not have enough power for a modern home family. Second, many insurance companies will not insure a house that is less than 100 amps. Like I said, I've seen them with 60, and obviously nowadays we're actually um, more energy efficient, but it seems like we're actually using more energy, which is really weird. So, um, it is what it is. In many cases, the listed information about a home may not be correct regarding the service amperage because brokers or owners rely solely on the size of the main breaker or fuse. Many people are also under the mistake impression that the total available service amperage is the total of the individual breakers or fuse in the service panel. One way for a home inspector to help communicate available amperage is to determine the implicity of the lowest rated or the weakest link in the following components: the service supply, the electrical meter and socket, the service entrance and conductor, the service disconnect, and the distribution panel. Here's a couple examples. A home inspector should describe the meter or the main disconnect amperage rating. The home inspector may also describe the 60 amp meter as potential inadequate. And like I said, you want to call this out. Don't alarm the customer, but alarm them. Say, look, this might not be suitable for you. You know, a 70-year-old woman that's buying a house like that, it might be. You don't know. So, here is a common layout for the configuration of how electrical system is laid out. It's a three-wire SDU service entrance cable runs from the meter outside the house into the main electrical panel board, and the panel board contains the branch circuits. In this common installation, the neutral wires, the white, should not touch the grounds, the green or the bare. Take a look at this illustration, take a screenshot of it so that you can get the proper terminology of it. And I'm not going to go through all that. And now here is the sub panel here. And you can see kind of the same thing, but in here we want the grounding bus bar not to be bonded, or sorry, the grounding bus bar to be bonded, but it should not be uh, connected to the neutral wires. Well, got to get that out in my head. Ooh. Okay, inspecting panel boards. Take a screenshot of this. You want to make sure that everything's safety. We've talked about this, missing knockouts, the bushings, the water intrusion, anything that looks outside the normal, overheating, dead front screws missing, or if they're incorrect, if they're pointed screws or stuff like that, you want to make sure that you are doing a good job in calling this out. And a lot of times, like if I see fuses in a house, a lot of times I will call those out too and say, look, you might need to have further evaluation from an electrician. Here are a couple of other weird things. One's in the bathroom. I have seen that, believe it or not. I opened up, couldn't find the electrical panel, and sure enough, it was in the bathroom. I followed the wires through the basement, and it went into the bathroom. I opened up the cabinet. There it is. I'm like, whoa. So I've actually seen similar to that one. So pretty funny. If you can't get to it, that's a really bad thing. So call that stuff out. Make sure that you're doing due diligence on this stuff because it can be problematic. If you see these Zinco panels, a lot of times those are not going to be insurable. So call those out. And there is a list of panels that are not good. And a lot of times what I'll do is I got a website for that and I'll throw that in my inspection report just so customers have it. Um, Anyways, double taps, you don't want to see any double taps. Remember, there is those two that do Cutler Hammer and Square D have, um, you can actually double tap both of those. Here, double tapping neutrals and design. So I did a mistake and I didn't read it right. I thought it said two wires maximum on a ground. And so I saw three, I called it out, and the electrician called me and said, "Hey, it says you can do it." And sure enough, he was right. So my bad, I didn't read it properly. So sometimes the manufacturer will say that you can have multiple wires underneath one lug, and that's okay. So the NEC does say that you can do that, and it all depends on who the manufacturer is. Here we got, again, wire size for the breakers. We've talked about this. We don't have to go into more depth of this. Again, I start with the lowest amperage and I kind of work my way up. And that's really the way to do it. Screenshot this next one here. This is understanding wire gauge from this old house. I love this old house. Matter of fact, I put a lot of their videos in my report because I really cherish what they say and they talk about what needs to happen, how to do it right, and so on and so forth. Because I want to give my customers the best inspection ever. So uh, here we got an AC breaker size. Now the this is where it gets kind of confusing because the wire sizes, if it's on an AC unit, it has startup energy. And that startup energy just needs to go through the wires one time and it comes back. For example, if a inspector observes a 50 amp AC breaker on an 8K wire, that may not be uh, a defect because it can do that because of that startup energy. So it's going to just start it up and then it's going to run idle for a while, so it's not going to heat up and stuff. That's why I like the thermal camera and stuff too. If I see something that's outside the normal, I will go for that. But the NEC and the IRC both have stuff for electrical panels, and you can read it on your own if you want, or chat GPT it or AI it or whatever you want to do. Even before thinking about or touching or inspecting or removing a dead front cover, the inspector really should look for those signs of water, moisture, staining, rust, things like that. Feel it with the back of your hand. Make sure that you're not feeling any energy. You can use um, a sniffer too, and just see what's going on. Any failure whatsoever, if you don't feel safe, make sure further evaluation. Here we got other panel boards that I would call out all three of these just because it's corroded, it's not looking good, it doesn't give me the thumbs up. It needs to be looked at by a certified electrician. Damaged panel boards, I've seen this happen before. We want to make sure we're calling this stuff out on a regular basis. Um, I just think it's funny. They got a tree growing in the middle of the one there. That is an air freshener for those who don't know. That's what was very common back in the day. We'd see those on mirrors a lot in cars. So, anyways, if you see anything like this, this is a prime example of not even to take off the dead front cover. Say further evaluation from an electrician. Done. There's too much going on here. I would not feel comfortable doing that. I'm sorry, but you're gonna have to have somebody else look at it. Fuses, Edison fuses were the best ones around. They blow when they're supposed to. They shut off the electricity. That's why I'm a big fan of fuses, but it isn't as convenient. And one of my houses that I owned had fuses in it. I loved it. Um, but we always had to have fuses handy just in case because our kitchen was some of them were 20 amp circuits and the other ones were 15. And well, my wife's like, just put a 20 in there. No, we can't do that. Just put a penny in there. My father-in-law said, no, what the heck is wrong with you? Don't do that. Um, these are these are fuse blocks typically used with electrical with AC units back in the day, and you'd see those quite a bit, and those would blow out. At least one of them would blow out, and then you'd have to go get uh, a replacement for it. Those were pretty common back in the day, and you'll still see them from time to time, but they're not as common as they used to be. Here are some um, uh, fuse blocks, which you have to pull those out, and you have to pull out each one of those to disconnect the power to the house. So both of them have to be removed. Here are some Edison-based fuses. I love these things. I just think they're cool. And they actually made ones that were breakers too, that you could actually push the button and stuff, but they never really caught on. And I don't know if you can find those anymore. There's several types of fuses available. Some blow very quickly, while others are designed to cope with a little bit extra power, such as like startup loads from electrical motors and stuff. And if you don't understand that, please take that, watch that video, Electricity 101. Here we have more fuse panels. You'll see these all the time, or used to see these all the time. You don't anymore, but they're really cool. When you're looking at panel boards, I've had this happen with brand new construction, taking out a screw and it blows a fuse. We want to make sure that we're calling that stuff out, and especially if it is a pointed fuse. The missing ledger, we talked about this. Make sure that everything is labeled um, for just in case you have to work on something, or the Lucy's bedroom. Don't label it Lucy's bedroom. That's number one. The way I was taught is you say first bedroom is the closest to the entryway, and then you go from there. Second bedroom, third bedroom, master bedroom, things like that. Um, if the panel board screw is there and it's in a sub panel, you want to make sure that you point that out to them that, hey, there's a grounding screw there. It should be taken out personally. But in all cases, look for the green headed screw if it is in a regular main breaker panel. Now, push Matic panels are very old, and this is that one that I was telling you about where the home inspector took off the electrical panel and it blew up in his face. Pushmatic was Federal Pacific, Zinco, Sylvania panels, and split bus panels. And like I said, you'll see those every once in a blue moon, but not very often. Um, Federal Pacific was, cutting edge technology, but they skimped a little bit, and they went out of business before they were actually called out as what do you call it? Before the lawsuit went into effect. So the inspector should just defer them to a licensed electrical contractor. Just do it. You save yourself a lot of headache. And same thing with anytime you see those pushmatic, you'll see those breakers. They are cool. I gotta say they look cool, but not safe. Um, Again, here are some more pictures of Zinco panels here, or the Zinco Sylvania panels. And I actually seen quite a bit of those in Minnesota. I haven't seen too many here in Florida since I moved here because I think the 4 point actually makes people um, upgrade them. Between 1950 and 1960, the split bus panels were pretty common. They're not too common anymore. And yeah, typically used to say further evaluation from you know what. Um, Phase. You're going to see these more on commercial buildings and stuff. And I go into a little bit more detail about this in the Electricity 101 course. And it's basically commercial agriculture. Some apartment buildings will still have these. This is what they typically look like. You got three phases going on, and then you got your neutral, and then you got your ground. So it's three wires. So three phase, three wires. The three-phase system looks similar to this here, but this is a Zinco commercial panel. Again, if you're going to look at this stuff, make sure that you are safe. Make sure that if you are going to take that dead front cover off, you know what the heck you're doing. And I just pray that nothing bad happens to you, especially for you commercial people that do a lot of commercial. I don't do a whole lot of commercial anymore. Um, People have done some weird things, done things like this with no panel. We don't want to see that anything that looks outside the normal. Definitely take a picture of it, send it on social media, and then say further evaluation from electrical contractor. Fuse panels here. Uh, a lot of times, like the fuse panels, I'd just say, you know, further evaluation from an electrician, you might want to consider upgrading to a more convenient source. That's kind of what I put in my report. Here are some non-metallic panels, and I've seen some plastic panels too lately, which was kind of cool. General Electric made this one here in 1970. Well, the plastics are coming back around, and I believe that they're going to be kind of the future here. Here's an old tackle box that somebody used. That hey, you know, uh, they definitely get an A for creativity for this one, I gotta say. Um, the doorbell transformers, anytime they're inside the panel, they have to be outside the panel. That's why you'll see it on top of the breaker box. So call those out. Say, hey, look, you can't have low voltage and high voltage in the same area. They don't get along. It's like having children, you know, in the bathtub with you when they're, you know, in their teenage years. You don't want that. I shouldn't have said that. That's wrong. Um, so that's kind of how it works. Here's your panel board inspection checklist. Go ahead and take a screenshot of this. I'll give you a few seconds and read through this. It kind of helps you out when you're doing these type of inspections, and you can just kind of check mark them off as you go. There is a video with Jim here. Jim is really awesome guy when you want to learn stuff about electrical or anything for that matter. He does sewer scopes and he's taught many courses. I've talked to him one-on-one. Just a great guy all around. Um, Him and his son are just phenomenal people, and he has a lot of videos out there that you can really learn a lot from him. And I really look up to this guy. So. Here are the common uh, uh, wire size for the non-metallic sheath cable, which is NM, commonly known as the brand Romex. NM cable is widely used. It's more cost efficient, it's easy to install, it's suitable for dry interior locations. Wires and cable standards in North America are established by organizations such as the UL, the CSA, the ASTM, the NEMA, and the ICEA. Totally useless knowledge. You don't even know that, but it's good to actually know what you're looking at here. So the underground feeder, the armored cable, the SE cable, and of course the Romax or the um, other cable. Conductor materials here. Again, copper, you got the tin copper, you got the aluminum, you got the copper clod. Basically what that is it's alum or copper with aluminum sheathing over it, and um, they've had pretty well success with that. But it does have some oxidization to it, so it should have that lubrication on there, and that's what the biggest thing with aluminum wiring is. You're gonna see a knob and tube. Anytime I see a house that's 1940s or stuff, I just tell my customers, there might be some knob and tube in the walls that we cannot see. So I always report further evaluation from a licensed electrician. We want to make sure that we're keeping our customers as safe as possible. And knob and tube, was one of the coolest things around back in the day. And it was porcelain fittings. They supported insulated conductors from from timbers and everything. It was just a really cool system, and space age. People thought it was going to be revolutionized, and as we've grown, we've learned a lot more. And when you're looking at stuff and realize what safety really is, and every year we're learning more and more. So keep up on these educational videos and webinars and stuff because we want to make sure that you're understanding what you're looking at and why. So here are some more armored cables. Yeah, I'm not going to go into too much detail here. The older cables lack a ground. Newer AC and MC cables include the ground with it. A lot of times, like you can use the outer shell as a ground, but you need the bonding um, clamps around there and make sure that you're following it around. So there, that's all I gotta say about that. Um, Here are a couple of things that you should look for, especially with the flexible conduit. A lot of times those are water resistant. Um, they normally you'll see them through air conditioners. Damage to the outer sheathing should be called out. A lot of times I will see this every once in a while. It doesn't happen too often, but I do see it every once in a while. And make sure that you're, being very vigilant on what you're looking at and telling your customers exactly what you see. Uh, that you don't want to allow moisture in there. You don't want to, have anybody get shocked or electrocuted. You just don't want to have it. Here is a really pretty rigid conduit system here, and I remember this video or this slide from last year, and I was like, man, they did such a pretty job. I mean, it's almost like looking at organ pipes. And I don't know, it's really cool. They're thick walled. It's rigid metal, and they bent them and made them look that beautiful. So just makes me want to cry. Just kidding. Um, Here we got many people use the Romex name, and that is not proper. It's NM. It's non-metallic cable. Though Romex is, pretty well um, known throughout the time. So, but non-metallic cable replaced a lot of that knob and tube wiring. And in most cases, residential wiring methods in the 1940s and 50s, modern non-metallic B cable was introduced in the 1980s and is rated for 90 degrees Celsius applications. Most non-metallic cables are black, white, and the bare green, of course. Romex is like Kleenex. It's a brand name. We know Kleenex as a tissue. If I go to your house, do you have a Kleenex? Everybody would hand me a tissue. And I look at it and like, this is the puffs. I'm not gonna do it. Just I'm too sensitive. Anyways, the type of cables, just whatever you're calling out, even if you do call it Romex, people know what you're talking about. So it's like that cable. So you got your underground feeder wire, and this is a pain to actually strip, but other than that, it works really good. It's very it's UV protected, it's bearable, so it's really good for garages. It's good for outdoor lighting. It's good for exterior equipment, things like that. And you want to just kind of keep an eye on that. A lot of times I'll see it like underneath decks and stuff that they're doing like a wiring job or in sheds. Um, uh, right around 1965, 1973, single-stranded aluminum wiring became really popular. And the I believe the copper price actually went skyrocketing those years. So they decided to use aluminum. Well, the problem with aluminum was that it didn't carry as much electricity long distances as the copper did, and but a properly maintained aluminum system is acceptable in most areas. It's where the aluminum hits like the copper, it's going to corrode. It's going to cause a major defect, and so if it's not properly maintained, you can actually have some major problems. And poor connections are one of them, and that's what they cause fires and stuff. The presence of single strand aluminum wiring may void a lot of those home insurance policies. So inspectors, make sure that you talk to your clients about that. Make sure they have the proper clips and stuff on there if they are uh, doing or if you see that aluminum. I've seen it quite a bit. Aluminum possesses certain qualities. One, that it does compare with copper, but it doesn't um, have it has too much ohms involved, too much resistance in it. And it corrodes if it comes in contact with a different type of metal. So the qualities all lead to loose connections and fire hazards. And uh, it is what it is. And here you can take a screenshot of this. You got that oxidization, and that's number one thing there. And it is what it is. I've also been told that in colder climates that it expands and contracts a little bit more than copper, but I'm not 100% sure about that claim. Aluminum wire was easily identified by its silver color and markings such as AL or aluminum on the on the jacket. So homes built or remodeled between 1965 and 1973 are more likely to contain aluminum branched wiring. Matter of fact, I just did a house that had all aluminum wiring and called the insurance company up and like these it's just not going to get insurance on it. They had a lot of other problems too, and when inspecting attics, make sure that you look at the jacket and make sure that, especially if it's in those years, be really diligent on the year the house was built, and kind of visualize. Okay, this was built in 1971, so there is possibility of aluminum wiring. There is possibility of this and this, and kind of build that little picture in your head before you even get to that inspection. So that way, you'll know a little bit more. Um, Options for the correction, and aluminum wiring should be evaluated by a qualified electrician. I've said that a thousand times because they're more experienced in this. They're good at evaluating and checking it. Not all licensed electricians are properly trained to deal with defective aluminum wiring, just FYI. Aluminum wiring can be a fire hazard, so we want to make sure that we call this stuff out if we see it. Again, if you see it. Since the early 1970s, several methods have been tried to improve the connections between aluminum wiring and junctions and receptacles and all that other fun stuff. The single biggest issue is that it's very difficult for a conductor to know where all the hidden junction boxes are in those older homes. You might be in the attic and there might be covered in insulation, and there's a junction box right there. You don't know. So it is that's why it's always better off to follow up with a um, licensed electrician with all these things. Um, Branch circuit connections here. Should one of the first thing inspectors should really check is whether the breaker size matches the conductor size. Like I said, I do start with the 15 amp or the 14 gauge wire. You know that that wire is the thinnest one most of the time, and then you kind of gauge it from there. You can always go to like a hardware store, maybe even get one of those gauges too that will actually help you, and they're plastic, and you can see what the gauge size is if you're really unsure of that. So some things that you can actually do. So there you go. I'm not going to go into too depth with this because neutral sharing lugs, again, if the panel board says that you can, but you want the same gauged wire in those when they are sharing that lug. So two 14 gauge wires, perfectly fine if the manufacturer says it is. But if it says, if you do a 14 gauge and a 12 gauge, you might have some issues there. So you want to make sure that you're looking at this stuff and just be vigilant on it. And if you see any scarring or scolding wires or anything like that, um, be notice that kind of stuff. So here's another picture here that the conductor definitely is oxidized there, but it also looks like they kind of trimmed too much of the electrical wire. So think about like you're putting all this pressure on and then it releases, and you're putting all this pressure on and releases, and it does that over time. It's going to start melting the rubber sheathing that it's on. So make sure all those lugs are properly seated. Uh, Oxidized paste, you're going to see this quite a bit on circuit, um, on your panels, that they put this paste on there to actually help with the oxidization so that it it's never really required, but you'll see it quite a bit, but it is permitted. So, and it allows the aluminum wire to have better conductivity with it and it doesn't oxidize as fast. Um, Abandoned wires, I always call out abandoned wires. If you see them, make sure that you're diligent enough. Matter of fact, I did a one inspection and then we had another inspector come out and he says, "Hey, did you see that abandoned wire in there?" And I missed it, totally missed it. I said, "No, I didn't." And haha, ah, dang it, because I don't like to miss stuff, and he knew I didn't too, and he knew I did that inspection too, so that was pretty funny. As you've seen this before, if you see anything like that, again, further evaluation. Basically, what's happening here is you got too much electrical going into that wire and it's burning up somewhere. It could be something down the line. It's not our job to decide why it's doing that. It's more of we see it, we're calling it out. Okay. I have actually seen it splices in wire. Now that is a hodgepodge mess there. If someone, I'm sorry, but if I was looking at a house to buy and I saw that, I'm like, man, how much do you want for this house? Because yeah, I'm definitely scratching my head because if that looks like that, the rest of the house, there's going to be some major issues in that house. But it'll be probably pretty fun to inspect, that's for sure. So make sure you're calling that stuff out. If you see something like that, and take a picture of it, send it on social media. That's a good advertisement for you. Again, lightning damage. I've seen this with that solar panel install when they had that arc flash. All the neutrals were burned. Everything was just, it looked like lightning strike hit it. It was so sad. And lightning strike, you never know what's going to happen with that. Lightning damage often affects the ground and the neutral conductors more than anything because lightning can actually happen from the ground up or it can happen from the sky down. Doesn't matter. It's You see it, make sure you call that out. Um, so here, protection of wires, you don't ever see like splices and stuff anywhere in the attic. I see this quite a bit. Matter of fact, I had a couple in my attic, and as soon as I moved in, I put a junction box right there, uh, and just wired it properly, so it actually looked better, and it was safer. So when I take people through my attic, I'll be like, "Hey, I fixed that right there." Pretty cool. Um, Exterior crawl spaces, basements, and attic accesses. The home inspector should report any exposed wiring whatsoever. We've talked about this. We've drilled it into your head. Make sure that anything that is um, exposed that you are taking it. Matter of fact, I went to a house and they didn't have a dead front cover. That is definitely a hazard. So make sure that you're calling things out like that. Here we have a wire that's going through steel beams. Make sure that they are, if they are going through it, that they have the protective sleeve around it so that they're not cutting the wire. Matter of fact, I had a couple of wires going through a conduit that didn't have the proper bushings on there, and it's trimming up that sheathing on there. So here we have a lot of support cables and Romex or the non-metallic cables. Yeah, I was just talking about that. Within 12 feet of metal boxes, make sure that it's 8 inches if it is plastic boxes. And again, like I said, just kind of eyeball it. You don't have to be perfect, but as long as it's somewhere around there. Every 4.5 feet, it should be stapled in. The AC cables within 12 feet and 4.5 feet, same thing. The MC cables within 12 inches of the box and every 6 feet. The EMT conduit within every 36 inches of the box and every 10 feet along that. Long support runs are often signs of improper installation and should be reported and further evaluation. Again, exposed wiring, we don't just protect your customers. If you see this, just call it out. It's that simple. You can take a screenshot of this habitat or all habited spaces require an electrical outlet within 6 feet, so you're not spreading those electrical um, extension cords all over the place. So while it may be a defect, it's worth pointing out to customers, especially on those older houses too. Um, Same thing here with receptacles. Make sure that they're mounted properly to the floor and make sure that they are sealed with that proper weatherproofing outlet top so that you don't spill into it. Um, in service, you're looking at locations in the kitchen and any wet area. You want to make sure that there's GFCIs. Kitchen countertops should have at least 12 inches required um, within any point of the countertop, not more than 24 inches from any outlet so that you can plug in multiple things around there and not stringing any electrical cords. That's the bottom line is you don't want to have electrical cords, and a lot of them aren't sized properly anyways when you're using those extension cords. So the goal of the rule of thumb is make electricity convenient enough for people so they don't have to use that. So that's it. Bathrooms and laundry areas within 3 feet. The home inspector is justified in suggesting that non-GFCI receptacles should be upgraded. And again, it's safety. That's all it is. And uh, yeah, look at that picture. Just this makes you scratch your head. Why would you think of doing that? What definitely, say that this may be a hazard here. Just saying. Garage and outlets, I've seen this too many times. Make sure that adequate lighting is required. You got to make sure that every every receptacle should be GFCI. Make sure that it's not painted. Make sure that they are mounted properly. If there's any ground or anything like that, make sure you're going around and checking that. Make sure that there's proper wire clamps in place. And um, remember, this is all a visual inspection. Everywhere on this whole entire inspection, it is all visual. You don't have to take off uh, you know, panel boards. You don't have to take off electrical outlet covers, things like that. Remember, it's just visual. You're going in there, you're visualizing what you see at that time of inspection. Okay. Um, Kitchen countertop, if you see any of these burn marks and stuff, I've called this out too, and actually made a couple of realtors mad at me because I called it out. Oh, why did you call it? Because it's a defect. Um, just if you see something like that, make sure you're calling that out. Inspecting, your receptacles, those three prong are out. I had seen that where the grounding prong is still stuck in the outlet. Yeah, you can call that stuff out. Just make sure that you're looking at stuff. I like to check out every outlet I possibly can. I know the system is, or the SOP says that you don't have to check them all, but I try to check every single outlet I possibly can. Matter of fact, I went to a new house yesterday, and it was they actually had a what do you call it, ground can't even think of it, reversed polarity on it. So the typical function of some of these testers, a lot of times I use the cheapest tester I possibly can. We're there to just make sure they're working. I'm not going to check every single one for 120 volts or 115 volts. I just want to check them all. And then I want to make sure that the GFCIs are tripping. That's pretty much it. The FCIs for purple. I got an AC or AFCI tester too, and I'll sometimes pull that out if I don't check it in the electrical panel. So want to make sure that the false grounds or the voltage that you might have seen this in older houses where um, there is a false ground or a bootleg ground. That's funny. Um, Sorry about that. Uh, I got a phone call. Sorry about that. Also, the voltage drop can indicate too many outlets on a service, poor connections, or undersized. You want to make sure that you're pulling all this stuff out. Also, ungrounded two-prong outlets. I always call these out. What you're supposed to do is you get one of these plugins that are adaptable, and then you're supposed to ground to that wire or to the screw there, and that's what that little hole is for, so that it becomes grounded. Um, and if you see ungrounded, it should look something like that on your tester. A lot of times I use I'm not going to put who I put it, but who I buy it from, but I use the cheap testers. They work great. They can still be grounded, so it's pretty cool. 240 volt terminations. Before 1996, many of the 240 volt appliances used three wire systems, which was two hots and one neutral. Later in 1996, new installations called for the four wires, so you had the grounding conductor on top of it. On a four wire system, the neutral and frame on must be removed. In a three wire system, it is extended or modified. It must be grounded to a four wire installation. So before 1996, it was common, and now not so much. Note, current NEC requirements may also require GFCI protection for dryer and receptacles depending on the code or the jurisdiction. So keep that in mind. Dryer outlets. Here is another video. You can screenshot this if you want to watch it. It's about 8 minutes and it just talks about what's going on. Give me a few seconds. Receptacle patterns. I'm not going to go too much in depth with it. The L-shaped ones were 30 amp, and the straight neutral slots are the rounded grounded slot. Those are the range. So when you're looking at the dryer, those are the L shape, and then the range is actually the lines in there. So those are the kind of the two different plugs that you would have to do. Um, like I said before, 1961, Charles developed the first GFCIs. In 1965, he patented it. In 1970s, it became more well strung. And in today's 1960, or today, it's in many homes, including bathrooms, kitchens, garages, and other locations, are all there. So GFCI is continuously to modernize the house a lot more convenient so that people aren't getting electrocuted or shocked. So you can always daisy chain them down. Remember, we talked about the line in, and then you have your load wires, and those push out past wherever that GFCI is. So that's kind of how they work. That's why the ones in the panel are a lot easier to install Um, Types of GFCIs, here are the two that are most common, the ones that are in the panel itself and ones that are push button. And we've seen probably both of them if you've been inspecting them for more than 5 days. So, um, common places for the GFCIs, we should all know this, and AFCIs. So take a screenshot of that. You know, you got your bedrooms, you got your um, uh, different areas where GFCIs are more common. Sometimes you'll find them both, AFCI and GFCIs, like in bathrooms, and it kind of gets a little complicated. But screenshot of this so you know what you're looking at, where GFCI should be, like your finished basements, your kitchens, things like that. Boathouses, damp locations. Any damp locations should have GFCIs. Just saying. Testing the GFCIs, I do recommend that you do the button. If you have the testers, go ahead and test the tester button. So that should help you there most of the time. Um, Arc fault, same thing. You want to test those. We've talked about this. AFCI protection started in 2021, and it now is pretty much in every house that I've seen now for new construction. Here's another video you can check out. Screenshot that. I have one similar to this one. Lighting, you want to make sure you have adequate lighting when you're going up and down the stairs and hallways. Make sure those three-way circuits are working properly. We don't want to see things like this. Make sure you're calling that stuff out, especially if you see the burn marks. That's why you don't see them in bedrooms anymore. Here's how three-ways actually work. Take a screenshot of that if you want. I'll give you 5 seconds. Sorry, time's up. That's basically how they work. And when I was an electrician course, we had to learn how to do that and do four ways and everything else. It was kind of fun. Switch receptacles. We're not going to really talk about this too much. You just got to make sure that everything is lit up properly. And especially like in bathroom stuff, don't have things overhanging the tub and walls and things like that. You just, yeah, not good. My wife wants to put a chandelier in our bathroom, and it would be not a good idea. It's not. And she says, I don't care about safety. I'm like, I do. So, recessed lights, some of them in incandescent light bulbs should not be used in closet. That's what I just explained. And some of those incandescent or some of those light fixtures shouldn't be even touching electrical. And so here are a couple meter sockets and auxiliary panels that you see. Make sure you're testing those AFCIs and then checking um, what wire size is going in to those panel boards. So, and if you see something like this where there's too much wire being sticking out, you might want to just kind of give your customers a good understanding. Make sure that the bushings and stuff are where they're supposed to be so the wire doesn't get trapped. Here's another example here of a knockout that doesn't really meet that bonding um, critique. So I would run a separate bonding wire to that. Um, Non-wet locations. Kind of skip through here. I've seen this too. A strangler is what we used to call them. We don't want to see that. So make sure that all strands are underneath those lugs. If you see any bus bar that is bent or corroded, make sure that you call those out too. Same thing with breakers that are not listed for the panel. I'm kind of weirded on that, so I'm not even going to talk about that right now. Test to push, that's what I've already told you. We're kind of going through a lot of the stuff that we already talked about. Um, any abandoned wires or if ones are disconnected, you might want to give those a little call. Same thing with multiple wire branch circuits. If you see double taps, things like that, we've already talked about this. Anything that looks outside the normal, just make sure that you're getting a good eye on this stuff. Like I said about that three-prong thing, guess what? This might actually be allowed, and sometimes it's not. So make sure you read that electrical panel board. Here's another picture of it. Too many underneath a clamp. Never a good idea. You're gonna have more problems than it's worth. So make sure you keep an eye on all this stuff. Yeah. Same thing here. You've seen this before. Can't tell you how many times. Anything that looks outside the normal. Matter of fact, I see it too often and it just makes me cringe. I've done so many times where I went to houses and they're missing screws, they're not labeled properly, there's knockouts missing, anything that's tampered with, make sure that you're just keeping an eye on there. Missing the utility tag is also considered tampering. So if you see that on that meter box, and if that meter box has openings, make sure you're calling that out too. But other than that, AJ, this is it.